The Kinetic Molecular Theory of Gases. This theory explains the molecular behavior of gases. Gases flow easier than liquids or solids because they have high viscosity. This is the observable property of gases. Gases are also miscible because the gases are mixed in any proportion in air. Compressibility is another observable property of gas. If an external force compresses a gas sample, the gas will decrease its volume. If you remove the external force, the volume increases. Gases are thermally expandable. When a gas sample is heated, its volume increases, and when it is cooled, its volume decreases. Different gases have the same temperature, have the same kind of kinetic energy too. When we say temperature, it is the average speed of all gas particles. If you will recall your kinetic equation, it is given as kinetic energy is equals to 1/2 m times v squared, where m is the mass and v is the velocity. Let us say, for example, that the kinetic energy for gas 1, is equals to 1/2 of m1 v1 squared, and the kinetic energy for gas number 2 is 1/2 of m2 v2 squared. Now, if they have the same temperature, then we can say that kinetic energy of gas 1 is equals to the kinetic energy of gas 2. Where m sub 1, this is the m sub 1, is the mass of lighter gas. So this can be given as 1/2 m1 v1 squared is equals to 1/2 m2 v2 squared. And if we're going to rearrange this again, this will give us m1 v1 squared is equals to m2 v2 squared. Let us rearrange this. So let us divide both sides by m sub 1. Okay, so that we can eliminate this. And now what is left is this. Okay, v1 squared is equals to v2 squared over by m sub 1. If m sub 1 is smaller than m sub 2, then our velocity 1 must be larger, and also it will have a greater velocity than heavier gases. Since there are too many gases, and every gas requires their own unique characteristics to be studied, scientists simplify the behavior of gas. Now, this unifying behavior, description or concept of a material is called ideal gas. So we can say that the material or the substance ideal gas does not really exist. It is an idea or concept that has something to do with the simplification of the description of all the gases. KMT tells us the following assumptions. Number 1, all matter consists of tiny particles that are in constant and random motion, meaning they are moving in different ways but in a straight line until they collide with the walls of their container, or until they collide with the other particles. This random motion is called Brownian motion, and the force exerted by the molecules as they hit the wall of the container is called gas pressure. Gas particles are much smaller than the distance between them. Most of the gas consists of empty space. The second one, gas particles are much smaller and the distances between them. Most of the gas consists of empty space. Now, number 3 is no kinetic energy is lost when gas particles collide with the walls of container, or even the other particles. The fourth one, all gases have the same average kinetic energy at a given temperature. As I told you earlier, temperature is a measure of average kinetic energy of particle in a sample matter. And kinetic energy and temperature are directly related, meaning the higher the temperature is, the greater the kinetic energy. Let us have another 2-minute pause. Explain the assumptions of the kinetic molecular theory.